Hello, my name is John Wrench with Unirac. We're here in Albuquerque, New Mexico on a solar install.
And I'm Brian Barton with Consolidated Solar Technologies here in Albuquerque, New Mexico, and we're going to be installing the array on a pitched roof house here in Albuquerque.
The following program will feature scenes from an actual photovoltaic or PV installation. In preparation, a good contractor will kick things off with a series of special tasks. Most importantly, safety is addressed. This is done by making sure proper precautions are taken and special equipment and instruction for the installation crew is delivered, educating the crew on generally how to install, the process and plan to be followed, as well as specifically tailoring each for the particular job is important. Most, if not all, tools used for a solar installation are widely available, but if they are missing the day you get started, you've already begun to negatively affect the profitability of the job due to time wasted running back to the office or to the hardware store. Remember, the solar modules are surfaced in glass. Even though it's tempered glass, it can still easily be broken. The silicon wafers laminated to the glass are very fragile. Now the contractor has to decide the best way to get all this stuff to the roof. Many clever ways have been developed for getting the modules up, but with the wind or other severe environmental conditions, even the best equipment won't get around those challenges. A lot of the other tools and equipment are rather easy to get up to the roof comparatively. We're on the roof now, locating the array installation area. We want to ensure optimum efficiency and minimize any adjustment at the end. An installer doesn't want to drill any more holes in the customer's roof than he has to. Finding the center of the installation area, positioning the array accordingly, and making sure the mounting structure is square is part of the process. Coordinating with the roof truss locations, once we find them, the mounting structure attachment points are the next part of this process. One would not want to assume that the center of the array will coincide with a rafter. There are several methods for finding rafters. Finding them at the soffits is a good way. Some contractors use drawings made beforehand that give key dimensions off the main north-south mark, coinciding with a rafter, and a main east-west mark. He can mark each of the module support beam locations right on the roof with a chalk line. He will want to make sure the beams are parallel to each other, perpendicular to the north-south mark, and that the array will look right on the roof before he drills the first hole. Ensuring squareness is a vital subject. Please refer to our centering and squaring video. A chalk line and roofing markers are tools the installer will use to make final locating marks. Now it's time to drill pilot holes for the lag bolts. This contractor chose to drill an access hole first. The access hole allows him to feel the rafter locations with a shaped wire. As previously mentioned, this is just one method to help be more precise in knowing the rafter location. The contractor is going to use a properly sized drill bit for this and make sure to aim the drill perpendicular to the roof surface. Roof trusses are usually made of timber 1.5 inches thick. The contractor wants to make every effort to center that pilot hole in the rafter. Next, the contractor is going to free up the shingle above the hole. He may have to extract some of the shingle nails that are in the way. He'll then insert the flashing, centering its hole over the one just drilled in the roof. Now the contractor can start fastening the beam and flange connectors together and fasten that subassembly to the roof. With this particular flashing system, a single lag bolt is used right through the flange connector and flashing and into the roof.
Hey Brian,
Hey, how's it going, John?
could you tell me a little bit of what you're doing here?
What we've done here, we've already installed our flashing that's our L foot's gonna set onto. Our L foot snaps onto the rail like so. And these, you want to make sure are facing uphill, up your roof. You always want your lag bolt to be at the top of your rail system for support.
Where would this go?
This goes right on in between here, like that, to give it more support and actually create a better seal so that we don't get a leak through our hole that's going into the roof.
No roof is perfectly flat, and PV installers have to contend with what is known as roof undulations, or peaks and valleys across the roof.
All right, could you tell me how you would level the system?
What we've done here is we've got our other rails already tightened down, and we've got our straight edge coming across here. And as you can see with the dip in this roof, we have to raise this one up. So we take these, which are really nice, really convenient because they just slide underneath and they bring us up whatever we have to, and then we can break off what we don't need. And at this point, it looks like we're going to have about 9 shims underneath. And you see it raises us up, and now we're planing out so that way our array turns out planeful. Then we'll take and snap these off, like so, and then we'll run the lag down and make everything tight.
Great, thank you very much.
Popular these days for many reasons is the microinverter. This is a smaller sized inverter that is mounted to the beam right under the module or modules it is servicing. The contractor simply affixes mounting brackets of the microinverter to the beam in between his module marks. He will then be able to attach the cabling system supplied with the microinverters. Handling the electrical wires to ensure a clean-looking array is important, and those wires, if not collected and fastened, could chafe in the wind against the roof. That could lead to serious customer dissatisfaction. So, the contractor uses a clip provided by the mounting structure manufacturer. The contractor marked the module frames earlier. It's a lot easier to do such things on the flat ground. This is going to really help him align modules as he goes and not rely on a bunch of adjustment at the end. The installers will connect the module leads before positioning on the beams. They will then slide a pair of end clamps in place, tighten them, and get the next module. Between modules, a mid clamp is inserted to hold down adjacent modules.
Hey Brian, could you tell us a little bit how you connect your solar modules together?
We use this device called a mid clamp, and it latches on to the rail system, and it's got sharp teeth on it. So it digs into the panel so it gets a really good hold. It snaps on like that, that'll set on top of there. And then you slide your other panel underneath, and when you tighten this down, it holds both panels, sort of like these over here are doing. And at the same time, it's also creating your electrical bond between your panels.
Electrically bonding metal pieces of the array and earth is required by most AHJs or inspectors. The contractor will want to be well schooled in what the rules are in his area before using any special device. Good mounting structure manufacturers provide tested devices to bond module frames and beams. End clamps are used at the ends of each row.
Could you explain how you tie in your last solar module?
We use these devices called end clamps here that slide onto the rail. And once again, they have the sharp teeth that dig into it. And these are really nice because they lock into the rail so you don't get any twisting action, so you get a really firm grip down. And if you notice, this part here slides to the outside of your rail, so it's going to be adjustable. So it'll fit pretty much any panel that you want to put on this railing system.
Great.
As far as attaching it.
The very last step is to double check everything: the look and position of the array, the bolt tightness or torque, and obviously that it is producing the electricity it is supposed to.
You can see behind me, we got our fully grid-tied photovoltaic system. It has been commissioned and inspected. The homeowner has already seen the benefits of this system. As you can see, pre-planning is key to any installation. Brian and his crew from Consolidated Solar has done an excellent job putting this system together. I'm John Wrench from Unirac. Thank you for watching this video.
Not all solar companies are created equal. In fact, there's a huge range in performance. So when you're looking at solar, from end to end, SunPower guarantees you the highest level of performance. proven to produce 36% more power than a conventional panel of the same size. Because our panels are so efficient, you get more power and energy in the same amount of space. When you're looking at solar, efficiency matters. In a side-by-side comparison, our panels continue to maintain high performance and don't degrade like most competitor panels. And because the real world is hard on solar panels, our testing goes above and beyond industry standards. True, you get a 25-year warranty, but we don't think you'll need it. SunPower panels are designed to last longer than that. With our uniquely well-trained dealers and installers, 24/7 monitoring, and around-the-clock service, we're there for you. People who know solar,
with Bob Howell, Barbara Allen, Chris Lincoln, and Don Woods. The most complete, up-to-the-minute news in the Southwest.
In the news, homegrown electricity. One local inventor claims he has the answer to the energy crisis.
I built this myself, man. It works.
Yeah, I mean, when it's windy, it is great, you know, because then the television works and the lights work, and oh my God, it's a good day when it's windy.
I really think this is the way of the future for everybody.
It's sort of slowing down. There is a problem, because when there's no wind, then we have no power.
Those are some details we're taking care of, but we know this is the future.
A new day has dawned for renewable energy, and SunPower is leading the way by harnessing the unlimited potential of the sun. We manufacture the world's most elegant and efficient solar panels with a uniform black design for superior aesthetics and increased power output.
For the first time, a consumer will have a solar power system on their roof that they're not ashamed of. The old solar was basically like a spaceship landed on the roof. Now you have a system that actually looks aesthetically pleasing, and the average passerby might not even see it.
A SunPower system works the moment sunlight hits the solar cells. It produces electricity even on cloudy days. The electric current generated flows to an inverter, where it becomes usable electricity that powers your house. When the system produces more than your home consumes, the electric meter spins backward, crediting your utility account. Systems can provide up to 100% of a home's electrical needs.
It's cleaner. You know, there's the green aspect, and it's much more energy efficient. And when we built a home, we designed it to get as much energy efficiency as possible.
You know, the sun is providing you basically, I mean, it feels like free electricity almost from the sun. You're just taking advantage of a natural resource and converting it to something, you know, really useful.
The best feeling that I've had out of this, whether it's an intangible or not, is I feel like we're finally in control of our energy costs.
There's no reason why every single house in America should not have a solar power system. And it'll be a standard feature, and you won't even have to think about it. It's just there.
Everything about the SunPower solar electric system is smarter. Standard solar cells feature unsightly metal grid lines across the front. At SunPower, we mount our electric conductors on the back of the cell. This breakthrough design leaves the top surface unobstructed and therefore able to absorb more sunlight. The backside also reflects mist particles of light up through the cell to achieve even greater power output.
A lot of people, when they first look at the size of a typical house, and they say, gee, there's enough area to generate your electricity with a standard solar panel. You go out there and then you find out there's some dormers and chimneys and some trees, and by the time you've down selected to the sweet spot of the roof, it's nowhere near a cost-effective solution. And by having a panel that puts out a lot more power than our competition means you get more energy for the same square footage on your roof.
We're making it much easier for the customer to get access to solar power. What we've done is we've partnered with installer dealers so that they can focus on customer satisfaction and customer service and excelling at putting systems up.
SunPower carefully selects and trains dealers to provide the highest level of quality and service. We conduct post-installation inspections and customer surveys to ensure that your SunPower experience is both professional and trouble-free.
They came out to the house, made an appointment, came out to the house, kind of explained, a lot about how the installation process would be like, determine where it might go on the roof to provide us with the most attractive solution and also give us the most energy output. And then when we actually did the installation, this big yellow box shows up with everything that they needed. They just parked it there for the period of time of the installation, which took a few days. It was actually a very simple and easy process as a homeowner.
There's really been no better time for solar power, and there are so many reasons why it makes sense. Number one is it's affordable. You can actually save money with solar power. You're freezing your electric bill because you're getting free energy from the sun, and as electric rates increase, the power from your solar power system stays the same in terms of cost.
More power translates into greater savings and therefore a better return on your investment. With a generous federal tax credit, state incentives, and our tax-deductible home equity loan program, a system can cost as little as $100 a month, which can be more than offset by energy savings, making a SunPower system cash flow positive from day one.
If you choose to finance it, your monthly savings will pay your monthly payment for the system. And the other thing I feel very strongly about is if it were a competitive market, our home would sell faster than a home that wasn't solar powered. So how do you say no to that? I don't think you do.
Now is the time to invest in solar. As you save on monthly electric bills, you'll be securing domestic energy resources and reducing your carbon footprint by taking advantage of the most widespread renewable energy on the planet.
Solar will one day be bigger than oil. It will be, I believe, the primary energy source for all of mankind. It's the most abundant energy resource on the planet, and what's tremendous about solar is now you can do something about it and do it in an easy way.
Not all solar companies are created equal. In fact, there's a huge range in performance. So when you're looking at solar, from end to end, SunPower guarantees you the highest level of performance. Proven to produce 36% more power than a conventional panel of the same size. Because our panels are so efficient, you get more power and energy in the same amount of space. When you're looking at solar, efficiency matters. In a side-by-side comparison, our panels continue to maintain high performance and don't degrade like most competitor panels. And because the real world is hard on solar panels, our testing goes above and beyond industry standards. True, you get a 25-year warranty, but we don't think you'll need it. SunPower panels are designed to last longer than that. With our uniquely well-trained dealers and installers, 24/7 monitoring, and around-the-clock service, we're there for you. People who know solar.
We're a family of 5 and very high energy users. Everything's plugged in at our house. It was easy for us to make a decision to explore going solar just because our monthly electrical bill was often close to $300. So it really made sense for us to think about what can we do to reduce our energy costs. Choosing SunPower made a lot of sense because we were wanting to have a system that was attractive. The panels themselves I know are very